Hello and welcome back to Geomorphic Processes. In the previous videos, we have already discussed exogenous processes. We have discussed that they are small-scale changes on the surface of the Earth and are composed of different processes such as weathering, mass wasting, erosion, transportation, and deposition. Now, we will be discussing the endogenous processes. So, in comparison to exogenous, which are small scale small scale and happens on the surface of the earth. Endogenous processes are large scale landform building and transforming processes. So in comparison to what we have discussed in the past, these happens in large scale. So it's capable of creating new islands, new continents, or destroying them. So they create relief. So if you can recall, relief means landforms. So they are capable of creating landforms. So first of all, the very famous endogenous process is tectonic processes, or you may just know as plate tectonics. So plate tectonics, I think you already know that our crust is not made up of one solid layer, but is actually made up of different pieces or plates, which are usually constantly moving against one another, under or above one another, because of the magma that is moving in our mantle. So this is also called diastrophism. So the different movements in our tectonic plates can be classified into three. So first you have folding, which creates structures called Antec Lines and synclines, and ultimately they form our mountain and mountain ranges. Next, we have faulting, which creates the rift valleys, and we also have lateral faulting, which is also called strike slip faults. Okay, so tectonic folding is quite simple. You have this horizontal layer and it will be pushed by other plates, which from being horizontal, it will now create this sort of zigzag formation. So depending on the amount of pressure and the amount of plate that is being pushed, you will create this large Antec line and syncline structure. So the one featured here in the picture is a small scale, because like a miniature one, and the upper part is called the Antec line and the lower part is called the syncline. So this is a miniature because I'm continuing from a pause because there was noise outside. But anyway, so tectonic folding is responsible for the formation of our mountains and mountain ranges. For example, Sierra Madre. So Sierra Madre is the longest mountain range in our country, and it's amazing because it's this long line of mountains, and it is formed because of tectonic folding. So the Philippines is situated, as you know, in the Pacific Ring of Fire, where plate fault lines are located. So since there are a lot of plate tectonic activity near our country, it results to volcanic activity and tectonic folding. So tectonic folding is the cause of the formation of most of our mountains. So the same case is true for the Himalayan mountain range. So the Himalayan mountain range is because of tectonic folding. So large-scale movement of landforms, which creates these large structures on our Earth's surface. So quite amazing if you think about it. Okay, so again, the Antec lines are the if you will imagine, this used to be a horizontal layer, but now it's sort of zigzag. So the Antec line is the one pointing upwards, while the synclines are the one pointing downwards. Okay, then you will also have tectonic faulting. So if in the first type, it only folds, this one cuts in between. So we have your one layer of plate, but in the middle, due to magma and high pressure underneath the surface, magma will start bursting out through the layer and create this large rift. So that large rift will be filled with magma temporarily, of course. So eventually, after the pressure has been released to the surface, the magma will cool down and water will start depositing in that area, like here in this picture. Okay, so a big Rift Valley is the one in Kenya. So the Great Rift Valley in Kenya, Africa. So if you can imagine, this one location used to be one normal layer, and then because of the pressure underneath the surface, magma erupts, okay, cutting through this layer. So this valley used to be filled with magma, but eventually it cooled down and water can now be seen flowing through the Great Rift Valley. So you so we can tell that these things had happened in the past because of plate tectonics, and we can predict that more of this will be happening in our future. Okay, then we have the third type of plate tectonic, which is lateral faulting. So if in the first scenario it folds, in the second scenario it creates a rift, in the third one it just moves laterally, so meaning side by side. So this is also called strike slip fault because they're slipping against one another or moving into two different directions, and that's the case in the West Valley Fault. So the West Valley Fault is a tectonic lateral fault line, which means once it moves, it's not going to move towards one another or away from one another. It's going to move against one another. It's actually the case for the San Andreas Fault. The San Andreas Fault is also a lateral fault line. So it's not like the movie where it will create a large rift. No, it's going to just slide against one another. But despite the seemingly small change, it can create very large effect to humans, of course, since we have created structures, and especially since this is a very big fault line. So it starts here, somewhere in Bulacan, and it extends downwards to Calamba. So we know that once this fault line moves, and we know that it will move because according to its history, it moves every 600 years, and we have already passed the 600 years. So once it moves, we know that there will be large effects to human structures, earth structures, and living things residing there. So I think we should be prepared. That's why there have been movement from the PVOCs before to become ready for the big one. Okay. Think if you are curious, you could also check if your location is near a fault line. So I'm going to share you this website here. So this website is called faultfinder.pbox.tos. Fault Finder. So Fault Finder, pbox Fault Finder, and this is the link. I will link it into our BBL page so that you can check for yourself. So this is a very useful tool that you can use to check if your house or your location is near a fault line. So you just search. It's like a drop down. For example, let's go to MCL. So Cabuyao is located in MCL is located in Pulo. Okay, and it will map where the nearest fault line is. So the school is 9.3 kilometers away from a fault line. So we're relatively safe if we are in school. So if you're curious, you could also search if your house or your home are located near a fault line. So the main thing here, the website focuses on the West Valley fault line. So or Luzon area mainly. Okay. So if there are people living in Alabang, this is a very, you will see there are individual fault lines aside from the major West Valley fault lines. So I do not recommend living in Alabang or Muntinlupa area. But yeah, if you live there, just make sure that your house is sturdy and you have an emergency bag so that you are prepared. Okay, so much for the tectonic lateral faulting. Okay, so that's just like a sneak peek of what we will be discussing in plate tectonics. I will be discussing more of how plate tectonics work and how the plates interact with one another in our next module. So our next module will be on plate tectonics. Okay, so let's just focus on the different exogenous process in this module. Endogenous process. Okay, so aside from the first type of endogenous process, which is plate tectonics, we also have your igneous processes. And you already know this as the formation of rocks or igneous rocks. We have volcanism, or as you can recall, the exogenous processes, which come from volcanic eruptions, or yes, volcanic eruptions. And you also have plutonisms, wherein it's the endogenous formation or an exogenic formation, endogenic formation of our igneous rocks. So more of that later. So volcanism versus plutonism. Okay, but before we discuss the formation of rocks, let's first discuss magma. So magma comes from igneous rocks, so that's what we'll be discussing first. So magma is a molten or semi-molten rock mixture found under the surface of the earth. This mixture is usually made up of 4 parts. So of course, you will have your semi-molten material, a hot liquid base called the melt, which is composed of molten rocks and minerals. Next, you have minerals crystallized by the melt. So the minerals located within the flowing magma have a high melting point. That's why they remain solid. Same goes with the solid rocks, which is incorporated in the magma. They have a high melting point. That's why they can maintain their structure despite the high temperature. And also, we have your dissolved gases. So, as you know, whenever we have tried to check if there is an possible volcanic eruption, we always check for 2 things. First, we check for earthquakes, which is a good sign of tectonic or volcanic activity, and also the presence of dissolved gases, because the formation of magma will always produce these gases, because that is a component of magma, the dissolved gases. So once magma is in your volcano, you know that you will be able to detect first the dissolved gases. So if there are high levels of volcanic gases, therefore you have magma coming for an eruption. Okay, so obviously they are extremely hot, between 700 degrees and 1300 degrees Celsius. So heat makes magma very fluid and dynamic. Okay, so magma, although we only reference it to volcanic eruptions, they are able to create new landforms, which I will give an example later, and they engage in physical and chemical transformations in a variety of different environments. So we will be discussing how these engagements occur by the formation of magma. Okay, so before that, let's take a look at the different types of magma. So yes, there are different types of magma. And I think if you look back at the videos of magma, you may have already watched in YouTube, you will notice that they flow differently. They even have different colors. So the type which is very light in color and even behaves like water, like there are splurts of magma which looks like a fountain, a water fountain, that is actually a basalt type of magma. So they're usually yellowish in color and they are low resistant to flow because of their high temperature. So that's 1160 degrees Celsius. So they are thin and runny lava and they move quickly down slope. Then in comparison, we have your rhyolite type of magma, which is have a lower temperature of only 900 degrees Celsius, and they are highly resistant to flow. So you will see this very slow moving type of magma, which is thick and sticky and have more of an orange color. So despite having the differences though in the consistency and their speed, they are still quite dangerous. Okay, so we'll stop here on the types of magma, and in the next video, we'll focus on the formation of magma.